Okay, welcome back everybody. This episode we're going to add a camera that follows the player around in Pygame to our existing code that we've done. So let's create a new file. Let's save as. And we'll call this camera.py. Can't spell today again. And we're in the right folder, so I'm going to put it here. So Pygame. Might need some settings, don't know yet, but let's import it anyway for what it's worth. So my camera, I want it to be a sprite group. So, and I'm going to put all my drawn sprites into this group. Then we're going to draw it offset to the center of the screen, to the player actually. So as the player moves around in the center of the screen, everything is drawn offset to give the illusion of movement. So this is going to be a sprite group. Obviously, we can give it a draw method for that, and we can update that logic as well in an update method. Pass the scene into here. So this is where I'll be calling the camera because everything's going to be drawn in the scene. So first, we want an offset that we're going to use. So this variable will be a vector. I think I just was able to go into settings. Yep, for Pygame, I can put vector to as vec. So I can just call vec. And I want to give the camera a bit of a delay. So I'm going to create a variable for this to make it easy to adjust. Just going to give it a delay of say 2 for now. Just give it an integer. Of course, we want an update. Now in this update, I also want to pass an extra variable of the target, which will most of the time be the player, but we want this quite flexible. So we can pass anything in here and the camera will follow it around. So we'll just call it target for the camera to follow. And we'll pass for now. And then we have a draw method. And in the draw, as per any other, we've got the screen, but I also want to pass the group of sprites that I want to draw. So we want to be drawing this group, so we need it in here. So state. So what we would like to do is let's start calling it in here. So of course from camera, let's put it up here because it's one of the first things we want to import. From camera, just the name of the file, import camera object. So now the camera's in here. Put this in here. So let's put it at the top before we draw the group, before we put the groups. Let's just call it camera. And if you remember, we passed in an extra parameter here, which is the scene. So we're in the scene here, so we just pass through itself. So that's our camera instantiated in the scene. We need to update the camera. Okay, and we passed through dt, the delta time. And we also passed through the target. So for simplicity at the minute, let's put self.player. as the target. And then we also want to draw the camera here. Draw. And remember, we passed in an extra parameter here. So if I recall, we passed in the screen into here, which is the game screen, and a group. So the group I want to pass in here is the drawn sprites. So everything I'm drawing to the screen, I want to pass through. So drawn sprites. Okay, see what that does when we run it. One required argument. So screen group. Camera.drawn. Of course, I obviously put this in wrong. We don't want to draw the drawn sprites on their own now because we're going to draw it in the camera and the camera's being drawn in the scene. So if we go to the camera and we can put the drawn sprites, which is the group we've passed in, group.draw screen, I think everything should just be there. Yes, and everything's still there. So we've just abstracted that into its own class. Now we can start playing around with the offset that we've got here to draw everything at an offset to the target in the update function. So let's first get our mouse position because I want it to move with the where we point the mouse. I want the camera to sort of pan across towards there as well. So just going to give the mouse position a variable so I can call it by mouse quite easily in here. And then offset X we'll do first, left and right, of course. Well, plus equal, which is just an easy way of doing this. The offset is equal to the offset plus something. So plus equal is just the easy way of typing it. And then let's say target dot rectangle dot center X. So the center of the player we want as the offset. And let's do the same for the Y position. And then here, I want to bring instead of filling the screen in the draw method, we only want the camera to be drawn. We can fill the screen in the camera here. So let's just copy that in here. Then let's loop through these sprites in the group and draw them with an offset. So for sprite in group, we can create an offset, which is equal to the sprite rect top left, which is the normal position, minus the offset. So as the offset's being updated, it will take it away from the position of the sprite. So as the offset's being updated, player's moving right, the offset's increasing. This will take it away from everything else. So the player will look like it's not moving, but the offset's increasing and therefore everything's moving left in the minus direction. So that should give us the result we require. And then of course I need to put these all on the screen. So screen split, the image of the sprite at the offset, the position we've just created. So let's see what that gives us. nothing happened, but it just flew away really quickly. So let's see what's the problem here. We don't want to add the offset here, we just want to make it equal. There we go. So the offset, which is the top left of the camera here, is equal to the center of the player. So you can just see the player up here in the top left. If I move down and right now, the camera will probably follow. There we go. Because in the update method of the camera, the position is equal to the center of the player. So all we really need to do is move that camera back by half a screen. And that should. Let's try that. Width divided by 2. And then the y direction would just be height divided by 2. That should put the player. There we are. And the camera follows the player around. So that's your basic simple camera that's always centered on the player. So let's make this a bit more advanced now. We've got a delay here, so let's use it. So firstly, I only want to draw things that are sort of within the screen size. So I'm going to call this self.visible window. And this would just be a rectangle. So the position doesn't matter when it's created in the camera because we can update it here every frame. So the X and Y top left position can be 0, 0 for now. And then we want it the width of the screen and the height for the width and height of the rectangle. So that will just give us a rectangle at the size of the screen. Then we can self.visible window dot X is equal self.offset. That should just be the top left. And then here, sprite in group, if sprite self.visible window.rect collides with sprite.rect. So for every sprite in this group, we're checking if the window collides with it. So that window that's always centered around the player, it will only then draw it on the screen. And I've found this optimizes it and makes the frame rate faster when you compare it because you're only drawing things that are on the screen. There's no draw logic for anything else. I think that's how it works. So let's run it. There's no attribute. Okay, let's just call it rect for now. I need to look in documents to use frect a bit more. Nope, that wasn't the problem. So there's no attribute rect because the visible window is a rect. So maybe frect was fine here. So that is a rectangle itself. I don't need to say .rect. I think that's right. Yes, that's right. So as you can see, it's only drawing things around the player. Because we can then make this half the size. So the visible window is now half the size, and that's only going to show the top left quarter of the screen. So remember, the X position of the visible window will always be at the offset, which is the player minus half the screen. Let's try that. There we go. So it's only drawing things that are in the top left of the screen, anything to the left of here and anything above this. So we know that's working. So you can change that to suit as you need. So that should be a bit of optimization for you, so you can make bigger levels. Because I used to find the bigger the rooms I had, started getting a massive performance penalty as it gets exponentially more computation. So a bit of optimization. Let's proceed with this. Let's start to make the camera a bit more dynamic. So with the offset, I want to adjust this by, so I want the offset to equal the offset plus, I'm going to put this in brackets, so it's 2. I want it minus the mouse position minus width divided by 2 mouse position X. So this is just a list here of 2. Mouse at position 0 is X, mouse at position 1 would be Y. And then minus X. And then I'm going to do the same with Y. Obviously this would need height. This would need 1. This would need to be Y. See what we've got with that, and it does. Plus equals offset Y plus offset equals offset Y plus this. That's what this means. Let's run it. Fantastic. So the offset is dynamic and now follows the mouse. So it will always be where the mouse is. So the mouse goes all the way to the right and the player will be all the way on the left. So it doesn't go as far. This bit here is half width minus the position of the mouse. We can divide that, say, by 2, and it should only go halfway across then. So as per standard mathematical operations, that division will always be done before these subtractions using BODMAS, BIDMAS. That still applies, so as long as you've got good high school maths, you'll be fine with coding these things and you should understand what's happening here. Let's run this. Now it should only go halfway across when I take the mouse right to the end. Yeah, or not as far, so we can adjust that as we. So I'm going to make that 4 because I don't want it to go too far. So there we go. It goes too far, so we can still move around and we can just adjust the camera to where we point the mouse. I've got my screen capture recording going here, so it seems a little bit laggy. When I'm not using that, it's not too bad, but it's still holding a good 60 FPS. When I uncap this FPS, it seems to run about 400 or 500 at this stage. I've only got an 8GB standard, 8GB of RAM standard i5 processor machine. So I think 500 FPS is pretty good. And then when I run it on OBS Studio with my screen capture software, it probably drops it right down to about 180, 200. So we can still hold a good 60 here. But the camera's a bit jerky. It snaps to the mouse position quite violently. And we're not going to know what's going on when there's a lot of action around. So I want it to sort of float towards it as such. So how can we do that? Well, if you remember, we gave it a delay. And anything that we change movement-wise, we do need to use our delta time. So we just times it by our delta time. So all of this, we're just going to times by our delay value times delta time. And that should simply work. There we go. I'm flicking it left and right as fast as I can, up and down, and it kind of smoothly goes towards it. If I increase that delay, let's make it 4, it should be even slower. Look at that. A bit faster actually, so make it less than 2, say 1.5. Let's make it 1. Here we go, super slow, snapping to the position. But it lags a bit too far behind the player. It's slower than the actual player can accelerate. It's 2 for now. I think 2 was working nicely for me on my previewed, the very first tutorial, which is what all this is based on. There we go. So if I hold the mouse and leave it in the same place, it will still sort of catch up with the player. It gives that nice sort of smooth movement, or tweening, as it's called, tweening to the position. Okay, I like that. That should be all. I want the camera to stop at the edges of the scene. But obviously every scene is going to be of a different size. So how can we dynamically capture that in code so we don't have to manually put it for every different scene? The way I did this was in my camera, because this is in reality where it's going to be used. I made a function called get the scene size. Self and scene. And this is why I passed scene into this class, because I'm going to need it here. So we're going to use some CSV functions. We can read up on this to get a better understanding of it. It basically imports a CSV file and gets things from it. So with open, we're going to open a CSV file. My file is placed in scenes folder in 0 for now, because that's what we give our name to our scene, our first scene. We can dynamically change this to the scene number, which we'll do later when we go on to room transitions. 0.csv. So when we exported from tiled in the previous video, remember we got the 0.csv for the tile set. So this opens this file. And its CSV is comma separated. So we want to return the new line when there is an empty string, and then open it as CSV file. So basically giving it that variable name. The reader is just a function, CSV reader. I want to read the CSV file. The delimiter is for the comma. So every cell is separated by a comma. So we're going to tell it to do that. Read it with delimiter as a comma. It's just how CSV files work. And for row in the reader, the rows so the sum is 1. Or in the reader. +1. We'll count the rows. Columns is simply the length of those rows. So if there's 20 rows that it's took out from here, which would be 20 tiles, 20 tiles down, so it'd be 20 rows. And we just get the length of the rows, and that gives us the columns. And then from here, we're just going to return. So I want the actual size in pixels. So we've got the number of tiles. So we just need to times that by the tile size, and that will be it in pixels. So that's my function for capturing the scene size. Now we can just call that at 0 or at position 1 because it's going to return both those values. Now we can use it to restrict our camera. So after the offset's moving in the update every frame, I want to check where it is and set it to the maximum or minimum of the level. So let's go with the X direction first. So we're going to use max and min functions here to keep it clean and tidy in the code. So basically whatever I put in here, it should return the maximum number. So this will return number 4. So if I put in here 0, because I don't want it to go below 0, and then I've got scene size, which is this function 0. Firstly, I'm going to create this as a variable because it's not going to change. Let's put it here. Self.scene size is equal to, wouldn't have worked anyway, as I called it get scene size. So now I can call it just from this variable. It's already initialized here, which I think saves some away OneDrive. So scene size, obviously at position 0. So that would be the maximum side of the scene, so right on the right hand side. However, our offset is the top left. So it would just carry on until the left side of the screen reached the edge. We want it to stop when the right side of the screen reaches the edge. So minus the width. So that should be the maximum position that the left side of the screen can reach, or offset X, top left of the camera. So while it's more than 0, it's always going to return the maximum of either this or that, which means that X will always be stuck at this. It's always going to be stuck on the right hand side. So if we do this for the Y, we can demonstrate that. Self.scene size 1 is the Y. So set Y. So now this should snap the camera basically to the bottom right of the scene, minus width minus height. So because the offset X, this number is always going to be greater than this. So let's run it and see. Argument scene. Obviously I need to pass scene into here. This requires a parameter. Here we've got the parameter. So just pop scene in here. Okay, right at the bottom right. So you can't see the player because it was up in the top left corner. But because I've got that offset minimum maximum, what happens if I go below 0? So I'm holding down the left key. So because I've got blocks there, no, there's no collisions on the blocks. I thought the camera would snap to 0. Oh. So if I do minimum, it will return the minimum. So the camera will then be the minimum of these two. So because the player is more than 0 in X and Y, should make the camera go to 0, return the minimum here. So let's try that. Yep. Now what I'll do is snap to 0, 0, because that's the minimum. So how can I make this done? So it carries on moving. We're going to keep this max function here. And then instead of sticking this there, we're going to put a minimum function here. So it returns the minimum of the current offset. Scene size 0 minus height. Sorry, minus width for the X. So therefore, it's always going to return the minimum of these two. So the self to offset will be fine, 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 all the way until it gets up to this point. And then out of these two, the offset will then be greater than this. So it's going to return the minimum, which would then be this. This would then be that smaller value than the offset. So it would stick on the right hand side. So let's test that out. So the Y value should stay on the top and snap to the top of the screen. But the X value should move right up until the right hand side and then stop. Let's see if that works. Okay. There we go. The player's up at the top somewhere. I'm just holding left now. I'm holding right down. And the player goes all the way to the end and the camera just stops there. There I am. There's the player. So no matter what I do, it just stops. Y direction. Let's just pop that there. Offset Y. Very careful. There we go. So if I go top left, it will just snap to the top left no matter what I do. Can't go further than that. And all the way to the right. It sticks there. And all the way to the bottom. There we go. And that is going to be done. Whatever zone or scene is loaded, it's just going to find the size of it from this, initialize it, and then use it to limit your camera. As simple as that. So one last thing I want to do with this camera, I want to use layers. So I want to just create some arbitrary layers to begin with. So I'm going to put that in my settings file so I can change it easily. So this is just going to be a list of strings. So I can just put the string into the sprite and it will determine what layer it's on, and then we can draw everything in order of the relevant layers. So for example, logically we'd probably have a background first, and then we would probably have objects, and then we would probably put the characters just in front of the objects to focus on them, and then we'd probably have particles above that. So this would be the bottom layer, and as I go to the right, these would be being drawn on top. So might be a bit more logical to do this. I might OCD with lining everything up. Particles, and then blocks. Let's just go with foreground for now. We don't need too much to begin with. We just want to show that it works. So there, I've got layers, it's a global variable, it's in the settings. And then we need to pass that into each sprite. So if I go to my characters, I remember we had this base NPC class, which the player inherits. So let's put it in here. They're all going to have. So let's call it a Z value for simplicity, because obviously it's layers. It's like a pseudo 3D, isn't it? So the layers are drawn behind and in front. So, and self.z is Z, as they would say in America. And the player also needs that Z passing in. I need to do that. I think I need to do that for the objects as well. So we made some objects before, so we want to put the Z value. Let's give it a default value of blocks. So the Z is going to be blocks. Then of course we've got C. So if we don't pass anything into here, into Z or surface, then all we need to do is that, and it's just going to be blocks by default, and it's just going to be a black tile by default, as we mentioned before. So let's start drawing these things according to the Z value. So object, if you remember, we used that for our blocks. So all the blocks that you see in the scene are blocks. And the player is also an object that's got a Z value now. So by default, remember we've got the groups, the position and the surface. Surface is given this. The Z is default. It's actually, because we've passed the surface in, it's going to think it's missing this. It's missing this, and that surface is going to go, whoa, this should be Z here. It's going to go, whoa, I don't recognize that as a string. This is a surface. So we do need to add it in here, actually. So now it's going to move along here and go, okay, this is the Z and this is the surf. So the Z is blocks. So remember, we're just passing strings in here. So all we have to do is make sure we've got these strings in our list of layers. And then let's give the player one. I think it was just before the name here. Let's put it on the same layer for now. Let's put it on the characters layer. So we add a layers called characters. And I think characters was, we didn't put blocks, did we? So let's put the characters on top of the blocks, or drawn on top of, so the blocks are behind the characters. Let's go to our camera. So here, obviously, if it's within a visible window, it will be drawn. And if sprite.z, so the z variable of the sprite, is equal to, we've not even got our layers yet, so we need to loop through our layers somehow. So before we do these sprites, let's loop through our layers. So the layer in layers, which is our global variable, sprite in group, and then we can go here. If the sprite is in the visible window, we draw it, and sprite.z value is equal to the layer. So it will loop through these layers and do this. So it'll go through the first layer and draw all these first. Then it will go through the second layer in the list and draw these, etc. And it will do that for the group in each layer. Go, okay, all these in the group, draw them, and then the next layer, draw these in the group. So let's see if that works. Okay, it's drawn on top, but I think that's what's happening before. Switch them around. Let's put the characters below the blocks. See if it makes a difference. And there we go. The player is behind the blocks. So my drawing order is fine. All you need to do is pass the relevant layer into the sprite and it will be drawn accordingly. So the next thing we're going to do, that should be all for the camera. That should get you going, should give you a nice camera to use in your game. We're going to move on to collisions. So we're going to get the player to collide with the walls and just give a basic collision framework you can use for all your objects. And I'll see you on the next one. Thanks for watching.